Let's move forward and implement an algorithm. All right, okay. So, I mean, once we get to a point where things get a bit more complex, then let's say, space of possible ways of solving a problem becomes larger, right? So a program that asks for a number and then adds 3 to that number, there are not many different ways in which you can implement that. No, there are not many different ways in which you can code that. But when you have to start making decisions about how you're going to treat the data, when is your conditional execution going to stop, what are going to be your success criteria, then things start to become interesting. So I am saying this not as a disclaimer, but in a way, so these are solutions that I thought were easy enough to understand and reasonable in terms of complexity, but you will very soon realize, once you start dealing with programming, that there's so many different ways in which a problem, even if it looks even if it looks quite simple, can be solved. Okay, so reminder, we want to have an algorithm that iterates over the sequence of characters in a name and finds the first vowel. And if that name has no vowels, the program has to say something along the lines of, this name doesn't have any vowels. So that's a quite interesting name. Okay, so here's the code for that. Our first line, as usual, is prompting the user for it. And now we have these variables are called flags in computing lingo or software lingo. So this is a flag. So this is a variable that will switch, will go up or down, will switch colors. Think of it as a switch. Once these found vowels, we start with found vowels set to false because we haven't found any vowels yet. So think of the program again. No, it's very useful to think of actual step-by-step instructions that go from top to bottom, and this line will only run once, and this line will only run once, and it will always be false the case that we have found vowels when we get here. This will change, but for now we will always have not found vowels. Now, what we do is we iterate over each of the characters in the name. And remember that this naming is arbitrary. It could have been anything. We know that there are 5 different vowels. So we check for 2 conditions. One of them is we check if this character is a vowel. There are different ways in which we could check if the character we are currently working with is a vowel, but I found this to be a nice and Pythonic way of checking. Technically we could do, if char equals A or char equals E, or right, but this would not look very nice. So this is why we can have this. We could always have something here, vowels, etc., etc. And also there are different ways. I am just doing Control-Z to go back to the original. There you go. And there's something else I want to check. Once I find a vowel, I am only interested in the first vowel in that name. So if I find the second vowel, I don't want to do anything. So I can have this flag, which will set to true once this thing happens for the first time. So we can already see the logic here, right? So this bit of code will only run once, because there will be only one case where we will find a vowel. I mean, once at most. There will be only one case where we will find a vowel, and these found vowels will be false, because this code sets the found vowels flag to true. And there you go. The first vowel in your name is this guy. However, it could be the case that after iterating over all the names in our variable, in our name, over all the characters in our name, we still haven't found any vowel. Well, our flag will still be false even after this bit of code has been executed. Thus, we would print wow, because to a certain extent surprising that your name has no vowels. And let's try this thing out. What do you think will happen here? Will we print A, O, or no, or no vowels? This is a tricky one. Not super tricky, but a bit tricky, right? We did not consider different casings. So Anthony, the first vowel, got skipped, and then we found O. Okay? A lot of O's. You see how it works, no? So I'm just going to say one thing. It could be technically possible that once we enter this bit of code, we do not want to iterate anymore over the vowels because we already have found the scenario we were looking for. So this, once we have this, once this code gets executed, if the name has more characters, this for loop will still happen. But we could actually have a way to stop the execution of this for loop because we already know. And if we, let's say you have, it's not the case, but let's say you have a name with 1,000,000 characters and the second character is the vowel, you don't want to iterate over all the remaining characters because you already have what you wanted. So you may want to skip all the rest. To do that, we have the break statement. It's not part. It's quite. It's not part of today's contents. But if you're curious about this, but it literally breaks a for loop. So we use it. We use it to leave loop for while loop. Typically use it when a condition is met. Right. So here. Okay. Now, after seeing, so we've got, okay, we've got a question here. I am a very big fan of regular expressions, so I think I will only answer that if I have the time because I want to give a good answer for this. But this gave me an idea maybe for a future seminar. Okay, now we're going to jump for. But yeah, short answer, we can certainly use regular expressions for ignoring case sensitivity here, but I would assume not everyone attending the seminar are familiar with regular expressions, so I will not spend too much time on it unless we have some free time, spare time at the end of the seminar. Okay, while loops. Again, no, by definition, as long as a logical condition is met, a block of code runs. And remember that in Python, we indent our code to mark different logical levels. And here's the syntax. And as you can see, we have a Boolean expression here. So a Boolean expression is a comparison or whether something exists or whether something has the size we wanted. In any case, as long as this Boolean expression is true, or false, but as long as this is happening, so you can say if we don't have anything in a list, then we run this code. And this is an example, a very small example where we initialize a variable a equals to 0, and we tell Python that as long as a has a value which is less than 4, please print the value of a. And here, this is well, an extension, right? So you see here that the outputs are printed one alongside the other instead of one after the other. By default, each print will happen in one new line, but you can tell Python to do it in the same line, where the end of the print statement is not the new line, but rather the space. So going back to the while loop itself, we have our a variable, which we will increment by 1 as long as it is as long as it is smaller than 4. Right? So this while loop will happen 4 times. The first time when it's 0, the second time when it's 1, the third time when it's 2, the fourth time when it's 3, and then once this a is equal to 4, this is no longer true, so this does not longer run. Okay, so these, purple, violet arrows indicate the iterative nature of these blocks. And to be honest, there's a bit more to programming, I mean, but there's not that much more. I mean, once you have, you wrap your idea, you wrap your head around some core ideas like data types and collections and well, logical functionalities, conditional executions, repeating operations. This is already a very complete toolbox that you can use for your own purposes. Okay, so let's have a small warm-up. So this is by far the easiest of the 3 exercises we have. Second one, it's a bit worse, but not much. And the vending machine exercise is my favorite because it's a bit more difficult. Okay, so what does this code do? Just leave maybe 30 seconds here. See if you can read this code and predict what the code is doing. Okay, so I hope you had some time to reflectively and critically look at this bit of code. We have a variable called position here, which we initialize with the 0 value. And we have a list here, fruits. And this is a list of strings where each string is the name of a fruit. Now, we start a while loop here where we say, while the value of position, which at the beginning is 0, is smaller than the length of this list. And for clarity, actually, let's do this. Let's take this cell here and run it, because I want to show you the length of this variable. So we have 4 elements, and therefore we have a variable of length 4. Now, while the value of the position variable is less than the length of the fruits list, we print this string, I love, and the fruits list, we retrieve the element at position. So in the first time that this code runs, this will be a 0, and then we increment the position variable by 1, and we concatenate our fruit with an S, and there you go. We just wrote a small program that does 2 things. It does several things, actually. It iterates over the elements of a list, prints a string for each of them, and it turns out that you can have grammatical plurals for these 4 nouns. It's not always the case, but here it just happens to be correct. Okay, so far so good, I hope. Now, here's the first example, the actual example, where we would write a ticking bomb. So think of it, what is the algorithm? In the movies, we've seen plenty of nail-biting scenes where the bomb is ticking and it starts, but the bomb starts ticking at a certain time, right? Depending on the well, yeah. Um, uh, my opinion about certain movies is probably not relevant to this seminar, but bottom line, these timers will always start at some point, and then their value gets decreased until a certain point, usually 0, and then the bomb explodes. Usually that's not the case. So we could actually write a simulator of a ticking bomb, a program that takes as input one numeric value, which would be the start of the timer. It will do one thing if the value reaches 0, which is when the timer reaches 0, then the bomb would explode. And our way of simulating that would simply to print boom. But this is only going to happen once. In all the other cases where the value of the timer is not 0, your program should print its value and then decrease by 1 to remind the main characters that how long they have to say the word. Okay, so the algorithm actually behind the timer in a ticking bomb is that simple to implement in Python. But there are a couple of particularities, that I would like to cover now. One of them is I said that back in the day we had several different input statements depending on whether we wanted to take as input a number or a string. But with Python 3.x, this got redone into one single input function. By default, this is a string, and we can check that. No, so let's have a into a test value goes here. I write 100, for example. You can see that we have the single quotes around this output. So we can indeed get the type of this variable, and it's a string. So this is the default value that we get from the input function. If we knew that we always would have an integer, a number to be entered in this cell, we could, by default, every time we get this input, then we would turn it into an integer. Of course, this is making a very strong assumption, and it's that every time whoever is going to enter the timer is going to enter it as a number, because we're using a computer, and let's think of an app, for example. But that's where the user interface can enforce, for example, that we cannot type letters, right? So here we would store under the timer value the user input, and then we will print this. And this is simply multiplying this equal sign by 50, simply to have a nice separator. So this will be, instead of writing 50 times this equal sign, we can do this. It's a shortcut. And then we have our actual algorithm, and it's quite easy, no? So while the timer is greater than 0, then we print that the value of the timer is whatever the timer it is, and then we decrease by 1. Quite stressful, isn't it? But that's how it is with ticking bombs. It's a stressful word. Right. So this is what we have. As you can see, Python is very cool. We can do a lot of things that when you start programming look very interesting, very cool, and it's extremely minimalistic. So there's very little actual programming to come up with good ideas. Okay, we're going to deal now with our latest exercise. This one is going to be about writing the algorithm of a vending machine. Are there any questions about what we've seen so far? Because we're doing quite well time-wise. So let's say, for example, 2 times 3. In case you haven't seen the question, someone is Blanca is asking about this print equals times 50. So let's say you've got 2 times 3, no? So this is a mathematical operation. The result of this is 6. Sometimes in programming, not all programming languages behave in the same way when dealing with data with different types. So here, for example, and I'm making things up. I am not sure if they are going to work, but this is probably not going to work. But it does. I thought maybe we had to do this, but no, this works. And the reason for this to work is because Python is let's say behind the scenes reinterpreting the value of the true type as an integer to make it fit the statement that we just wrote. This is the same. This is the same as we have a list which is 1, 2, and say A plus A. And this is just the behavior of Python, right? So it turns out that instead of writing 10 times the equal sign, you can actually multiply it, and that's the behavior of the programming language. But as I say, no, if you then start, I am not super familiar with all of them, but if you start playing with JavaScript or with R, I am pretty confident that not all of them behave the same way as Python. So you would have to look into what you can do and what you cannot do with combining different data types. I see more questions, but I think I will move forward. And if possible, they're very good questions, but I would like to go back to them at least after we are done with the vending machine exercise. Okay. Vending machines, lifesavers, often source of calories and saturated fat. And actually, turns out that with a mechanism that we can implement in Python in our second session. So that's quite good. We're going to write an algorithm that kind of simulates what usually happens in a vending machine, no? And that's also a very, engineering-like way of approaching things, no? So think of the small steps, break a scenario, a context, a situation into smaller problems. Try to think of ways to solve each individual problem, and once you've got that, then you are in a much better position to solve that apparently complicated problem that looked like in the first place. Right. So you probably know, no? Sometimes in a vending machine, you throw the money first and then choose, or in I think the more modern ones, you have the pain, then you choose your product first, and then you have to throw in money until you pay for it. So the second case is the one that we're going to simulate. So we would first choose a product among some choices, and we will simulate these choices with a Python object. Then the vending machine will unfortunately expect us to pay for it. So because we want that product, we're going to throw in money, which is added to a counter until we have entered at least, and this is important, at least the price of the product, but it could be more. Now, what happens when we overpay? In the best scenario possible, we get the product and our change back. I say maybe because we may have entered the exact amount. Okay, so these are the logical steps that we're going to implement in our vending machine algorithm. And this is the code. And as you can see, a lot of print statements. So actual logic, there's not that much. Again, no, this is a simulation that we're going to use, that we are going to discuss only with Python objects. Our the first thing we need is the actual vending machine, and we have simulated the vending machine with a Python dictionary where we have a product and the price in the monetary value you prefer. I think in my example I use pounds, but this is generic. So we have a dictionary where by default all our keys are strings and the values are the prices. Here we have this line, which is simply going to, this is for showing in a prettier way our products. Remember that we said that we could access a dictionary's keys by calling the keys function on that dictionary object. But this would print a rather ugly Python output. What we can do is we can use this join statement. I hope there's a bit of time to go over this because it's also very useful to know. But this is only this is just an aesthetic line. It doesn't really do anything in terms of logic. And the operation is the same, no? So the way we approach the problem is exactly the same as in the vowel counting algorithm. So in that one, we had a flag, a binary flag, true, false, true, which started as false and became true once all the conditions that our algorithm required were met. But now we cannot really have, I mean, we are going to operate with an incremental, with an incrementable value, which we call, which we name with the self-explanatory name paid so far. And once we have this, so we have our vending machine and we have the amount that the vending machine knows that we have paid so far, and whenever we go into a vending machine, it's always 0. So this is always going to be true, and this is good because we can set up a scenario where we have some statements about the world that we know that are going always to be true. But then start the choices, and that's actually very appropriate to say, because what we're actually going to do is to choose one product among the products, no? So we have our products list. So again, no. We have our choice here, and our choice variable will get the result of entering something, and we prompt to the user the list of products we retrieved in the previous lines of code. And now we enter the money counting mode. So this is when we actually start throwing money into the vending machine until we have satisfied a certain criteria. With a certain criterion. Which criterion? Well, that what we paid so far is not less than the prices here. Because while we have paid less than the price of the product, we need to pay more, basically. So here we've got a few nice prints, and we have a variable called payment, which will be prompted by the user here. So please give me money. Now, the money I enter is going to be a string type. So I am going to turn it into a float. Why? Because someone could add cents. No? So 125, this should be a valid option. And remember that Python, instead of complaining, so let's say payment is 10, right? So, and type of payment. Of course, this is an integer. If we do this is a floating point number type, so it means it has decimals. But we could actually do print the integer of payment, and as you can see, it gets rounded. But I mean, this is not great, right? So we may want to do this in certain situations, but here, I mean, they're not very expensive prices, so we definitely want to have a look at keep an eye on the decimal. So this is why the input that we're entering, we convert that into a float. And again, this is the strong assumption that whatever we enter in this line is actually a number that can be converted into a float, because You cannot convert a string to a float. Now, once I pay, I use the paid so far variable to keep track of what I have paid so far. Now, when this condition stops being true, I am in a situation where I have paid so far is at least equal. Better like this. I am in a situation where paid so far is at least equal than the price of the product. Now, if that's the case, now we have two possible outcomes: that we actually paid the exact amount, or that we paid more. If we pay more, we need to get the difference between what the product cost and what we paid. Okay. Okay, let's have a run. Let's see a couple of examples, and I'll explain a couple of things. I think I've written things that are not necessary, but we'll discuss them later. Okay, so now select your choice among soda can, chocobar, energy drink, and here we've got the prices. So let's say I want a chocobar, but let's say I don't have chocolate bar, right? So now we have entered the money counting mode. So far we have paid. So the first time we enter here, this line will always print 0, and it will always print the product of this guy. And we enter some money. So let's enter, for example, £1. So paid so far is still less than the price of the chocolate bar. So I enter more money again, another £1. I don't have any change. So here you go, the product, and here is your change. I wrote these apps, but forget about it. If you, it's not necessary. Forget you ever saw that. When we are in this block of code, we know that paid so far is at least equal to prices. So we can take the price and remove and subtract what we have paid so far. Actually, it should be the other way around. No? So we paid so far minus the price, because we know that at least they're going to be equal. Let's try the energy drink. Energy drink. Cost £3. So first I say 2.15, and let's say two more 15. Okay, so it cost £3. I entered £5. I get back £2. Okay, so this is the algorithm for a vending machine. What I would like now is to, stop for maybe 30 seconds and let you think of how could you break the program. You are a user and you have several ways to interact with the program. Well, two, I think. So it's good not to think how this program behaves and what are failure criteria. So what could possibly happen for this program to not behave as expected, or to crash, to find some case scenario where maybe two data types are not compatible, or maybe there's a certain situation we did not account for when we wrote the code, and maybe we enter an infinite loop and the program gets stuck forever. No, it's not really highly possible here because it's not that complicated, but to be fair, the only case would be here, no, where we have the chance to break the program by paying with something which is not a number. Actually, no, but this will this work? Cannot convert a string to a float. I think the way we should have done that is to convert it first to an integer and then to a float. If I have integer of true, there you go. this is just a curiosity, no? But we could actually do this. This would have the problem that we would be rounding the money, but it would allow us to pay with the true string. I think this is quite hilarious. Ah, no, yeah, yeah. Actually, yeah, I'm not sure why this is happening. Maybe we can figure it out together. Okay, so there you go. A case where we implemented algorithm inside a vending machine, and we kind of broke it a bit. Not because we actually broke it, because we wrote faulty code. Okay, so we're going to jump into the next and final bit of our seminar. And this is a whole it's quite large, no, the topic of dealing with files, but it's really useful, so I'm sure you're excited about it. So first, let's give a little bit of context. Let's get rid of this very ugly error. Yeah, this is better. Okay, so files. Why do we need this? No, why are we interested in files? Well, what happens in computing is that in all programs that we've seen so far, data disappears, right? So everything that happened in the previous snippets of code, it really got lost when the program got terminated. This data, no, the computations, the data, the stored variables, and so on, that this only existed in the machine's memory. But sometimes, and especially if we actually want to do something useful with our code, we want to produce programs that generate data which is persistent, which is permanently stored, maybe a database, a hard drive, a USB stick, the cloud, you name it, no? And the simplest way to store data is actual files that you have in your hard drive. There's a small caveat here, and we're going to look at files in the context of Google Drive. What does this mean? This means that once you figure out and learn how to deal with files in Google Drive, you can also, for you, it will be actually quite easy to do the same thing in your local machine, because there's a layer, not much, no, but there's a small layer of complexity that we have to consider when we're dealing with Google Drive and Colab and so on. That doesn't happen when we deal with our own machine, our own file structure, our own operating system, and so on. So what's the syntax for dealing with files? This is the most basic syntax, where we have the open keyword followed by the path to a file and the access mode. This path can be relative, so Python will by default look at the file inside the same folder where you're running your notebook or your program, or this actual Colab notebook as well, if we don't provide an actual path. So this line of code, f equals open myfile.txt, right? It will always create a file called myfile.txt in the same folder where from which I am running this notebook. And the W is the access mode. So this means that in this case, it's W, which stands for write. So this will always be, work, right? Because we will always be able to create a file, myfile.txt, with the write mode. What would happen if we already had a myfile.txt in that same folder? So then that myfile.txt would immediately get deleted because it will be created by this Python line. Okay, so it's something to be careful about. There you go. There are other read access modes. What we want know, that if at the end of the seminar we know about the read and the write mode, I think it's more than enough. But we're going to add one more, no? So we're going to look at 3 access modes. I'll just write it here. We have the W mode for writing. So this means create a blank file. The read mode for reading a file, and the A mode for reading a file to which we can append data. Again, this is a bit of Python history, but I think it's relevant. So back in the day, with the syntax was you open a file, you do something with it, and then you close it. And the reason is because sometimes the contents of the file get stored in the buffer of the machine. So to actually have everything that you have in memory to be stored in the actual file, you need to do this. But now we have this operation, which is actually very similar to the other program flow syntax bits that we saw. We have, let's call this an environment. So we have the open file environment under which we have some code, and this code is expected to do something with this file. And the syntax is this, no? With open, then a path, and then operation access mode. So for now, let's just consider these 3 as this is a variable, this is arbitrary, we can call it whatever we want, and then we write some code, right? So if we say with open example.txt as read in the read format, in the read mode as the f variable, and then we call the read method. The read method reads all the contents of a file as a string. So this would read the 5 first characters, not the 5 first lines, but the 5 first characters of the file. Once this is, then we can of course write more code. But once this is done, when we leave this environment, the file has been automatically closed. So we don't really need f.close anymore. So this is just to give you a little bit of context. When you do this, you don't really need either the open in a different line, and you certainly don't need to close the file manually, because it will be closed automatically once you leave this indented block of code. Okay. So let's deal with files in Colab, and let's have a look at some an example of, you guessed it, Spanish foods. This is something that you do need in Google Colab, and what we're going to do is we're going to load a file I have stored in my Google Drive and read its contents. I'm going to leave the full screen mode because I want to show you this. No, so this is the folder where I have stored all the images that I've used in the seminar, but I also have, I have a text file called Spanish foods, and we can preview it. And as you can see, this is a list of Spanish foods that I got from Wikipedia, and as you can see, they are sorted in alphabetical order. We're going to have our last example where we read the contents of these lines. I'm not really, I would love to go into details about all these foods. All you need to know is all of them are excellent and delicious. So what we are going to do with this file is we're going to read the contents of it, and then we're going to save the file, another file, but in a different order. The order will be based on the length of these guys. So the first line will be this, and the last one will probably be this one because it only has 5 characters. So this one at the top and this one at the bottom. Okay? Okay. So how do we do that? You see this left pane here. So we have the table of contents here. We've got some help, but we also have a directory. And as you can see here, we only have a temporary folder that Google Colab created when we started our notebook. With this snippet of code, Google will give us a URL that we click. We select which Google account we're working with. We let Google do anything it wants, really. And we get this code. What we do is we click here, copy the code, go back, paste the code, enter, and it takes a little bit. Once this is done, we will have access to our Google Drive. While this is thinking, I want to mention that we will be able to see our Google Drive folder here, but I already know that the path is this guy. This is the path to the folder here. The path is the path to this folder here, this one. And the file I'm interested in is this one. Still thinking. Okay, so this is not going to break, even if this is not mounted yet. So it's called mounted, to mount the file system into this particular environment. Yeah, it will. We have to wait, right? Because this needs to be happening before. Once this cell is done, then it will automatically jump to the next cell we executed. So if you're kind of impatient, you can start running cells, but they will not run until this is done with. Usually it takes less than this. Let's try again then. It may be the case that we have to restart the notebook, but to be honest, this is not something that's happened to me before. Let's try again. It takes a very long time. Let's do something. Let's reload. When we reload, something that happens here is that you see that it's connecting and initializing. So now we are connected. Sometimes simply, redoing the whole thing works. There you go. Now it took like a millisecond. Okay, so now what would happen now? There you go. So here's my drive, right? So drive, my drive, and here you got the sneak peek of my. It takes a while because I've got a lot of folders here. But yeah, so now I can do this, and I can actually open my file. No error code, no error message. So this means that I have successfully stored in the F variable the file SpanishFoods.txt with the A access mode, which means this means that we can read and add stuff to the file. Okay. Now, two things that you are going to that we're going to see today are one of them is the read method, which you already saw. So we take the open operation just like here, but this is just to show you that if we do not pass any access mode, Python by default will treat it as a read mode. So if we don't say anything here or here, Python will by default expect that this is something that you want to read. You don't want to write on it. You don't want to open it as in append mode. And we've got two methods. One of them is read lines, and the other one is read. When you do .read lines, and it has the parentheses here, so this means it's an actual function, so it will do something. We read the lines of the file located in this path, but if we do read, it will read the whole content of the file as a string and store it in raw. That's why I wrote raw, because it's the raw content of the file. So let's do this. Now, the ls variable contains lines. So let's have a look at the lines between 12 and 14 position. And as you can see, we have an end of character. It's always the new line character, right? So this is a list where we have one line, each element is a string. It's one of the Spanish foods, but the last character is always the new line, no? The carriage return. But we could always also get the first 200 characters. And because we did a print, when we print these guys too, and when we print this, it actually goes into the next line. If we skip the print statement and we simply ask Python to show the content of this variable, what we see is the line, the new line, the second line, and the new line. But it's really much prettier to do this in here. Okay, and we can have a look at the last line, but with the -1 index, and it's this food here. It's a Z. Okay, so our very last algorithm, we're going to write this algorithm for sorting foods by length, and we're going to do it. This is heavily commented code because it's logically it might be a bit difficult to follow along. Okay, so what do we do first? We first read foods as a list of foods, just like we did before. This is exactly the same content as the ls variable here. Remember that what we want is to have another file stored in this folder with the sorted foods by length. So this, I heavily commented this, so I think this is fine if I only read, and hopefully this makes sense. So this is the same situation, right? So we are breaking down the problem of reading a file which has, let's say, unsorted elements and arranging them based on a certain criteria. So the approach is going to be this. We are going to take the food list stored in the foods variable. We're going to take the longest element in that food list, and we're going to store it into sorted foods, into the sorted foods list, which will be empty at the beginning. It will then have the longest food we have in foods. But once this has happened once, what we do is we remove the longest element from the original list, and then we run again. So this while foods is a shortcut for while foods is not empty list or is not none. Maybe this would work. This may work as well. So this is a while loop that's telling Python this has to happen as long as my foods list has at least one element. The moment I remove the last element in my foods variable, then I am going to leave this. Actually, this is the whole thing. And so this is the whole thing. And how do we check for the longest one? Well, we set a variable called max length at a random, it doesn't really matter, but small number, small enough to make it smaller than the smallest length in our list. And because we know that the lengths are positive numbers, this is enough. So we will never find an element with a length less than -1. So this is fine, because this is going to be our comparison value. And now what we do is we iterate over each food in our list of foods for food in foods. And now we check if the food that we found is high, the length is higher than the value of max length. For the first one, it for sure will be yes. Now, if that's the case, we set max length to the length of that food. And we set the longest food to that actual food. When our program has iterated over all the foods in the foods variable, what we have is the longest food in that version, quote, quote, version of the foods variable. And why am I saying version? Because once we find the longest one, we remember the append method, which adds one element to a list. We add the longest food to sorted foods. And here I did a small trick. So here I add the longest food, all characters, but the last one. So here I am getting from the beginning to the last element -1 to remove the end of line character, because I will concatenate it later, just to show you the slicing operation. And then I have, at this point, I have found the longest food in my foods variable. So now I get rid of it. So this food variable will have one less element each time this while loop happens, until it doesn't have anything in it. Okay. Now let's check for foods first. And as you can see, it's an empty list now, because we got rid of one food line at a time, and our sorted foods are these guys: longest string and shortest string. And then once we have this variable here, now we can store it in our Google Drive. How? We open data directory path, which is right here. We concatenate to that our file path, which is this guy. But then we also concatenate a suffix. Let's call it a suffix. And this is going to be underscore sorted.txt and with the right mode as outf, which stands for output file. And then what we do is we iterate for each of the elements in the sorted foods list, and we write in our output file, which is located here, the value of x, and we concatenate this new line character. I've done this because usually it may be the case that the list doesn't really come from a file. In this case, if we remove this and remove this, the result would have been the same. Okay? We run this guy here, come back. I think it refreshes automatically, maybe. Do I have to do a find? No, there you go. It showed, preview, a beautifully arranged output file with each of these, please let me insist, excellent foods sorted by order, order being the length of each of their strings. Okay, so this actually marks the end of the seminar. And